Good afternoon. Today we are going to look at ions, which are charged particles, and this will be another kind of a review video because you did start looking at ions in the last unit. So here's what we're going to review. First of all, why do atoms move electrons around to even form ions? Well, remember that they do it to become more stable. Atoms gain or lose electrons. You do already know that. But now in this unit, because of the electron configurations, we know that the reason they do it is to get that full outer shell, or the octet. Now remember, in a neutral atom, the charge overall is 0. The number of positive protons in the nucleus is the same as the number of negative electrons that are out in the electron cloud. But in an ion, there are different numbers of protons and electrons, so that the overall charge of an ion is not 0. We are going to look at how to draw valence electrons on paper. And the way we're going to do that is with a diagram called a Lewis diagram. Now, there are 4 steps to draw a good Lewis diagram. You want to write the symbol for your element. You're going to draw the valence electrons as dots around the symbol, and we're going to draw them on all 4 sides of the element symbol with no more than 2 on each side. Let's work a couple of examples so you'll know what I'm talking about. We're going to look at sodium and chlorine. So let's start with sodium. We're going to write the symbol Na. Now if you get a periodic table and look, find where sodium is located, it is in group 1, which means that sodium has 1 valence electron. So we're going to represent that with 1 dot. That's the Lewis dot diagram for sodium. Now let's try chlorine. Again, the symbol first, Cl. Grab your periodic table and find the location of chlorine. I see that chlorine is located in group 17 on the periodic table. That means that it has 7 valence electrons. So using dots for those 7, I'm going to add them. I'm going to put 1 on each side of the symbol for chlorine, and then I'm going to go back and just pair up a few of them until I have 7 dots total. That represents chlorine and its 7 valence electrons. Those are the ones that are going to do the chemistry. Now, what happens if the sodium atom becomes an ion? Well, remember that all atoms are trying to get their full outer shell. Sodium has 1 valence electron, so it can add 7 electrons. 1 plus 7 is 8. Or it can get rid of the 1 that it already has, and the shell that's underneath that one will then be full. So which sounds easier to you? I think getting rid of 1 sounds easier than adding 7. And that's what we see sodium do. That 1 valence electron is going to disappear, and when it disappears, think about what that does to the charges. We've lost 1 negative electron. So an atom that loses electrons is going to end up with a positive charge. That's the notation for the sodium ion. Now let's try chlorine. Chlorine already has 7 valence electrons. It wants 8, or the octet. So it can add 1, or it can lose the 7 that it already has and give them away so that the underneath shell will be the full outer shell. Well, I think that adding 1 sounds easier than losing 7. So that's what we see chlorine do. It's going to add 1 extra electron. Now think about the charges. We have the same number of protons in the nucleus for chlorine, but we've added 1 extra negative electron. That gives the chlorine ion an overall negative charge, as I indicated in that symbol now. Now I've left you magnesium and oxygen in your notes. Why don't you try writing the dot diagrams for those atoms and then figure out what charge ions the magnesium and the oxygen will form. And I'll give you some time to do that. Pause this video, and when you're done, come back and you can finish watching. Alright, the last thing you need to know is the names of these positive and negative ions. A positively charged ion we call a cation. Remember, the T in the middle of that word is a plus sign. And then chlorine is a negative ion, or an anion. Those are the terms that we use for any positive or negative ion, respectively. So I hope that review helped. Bring all this notes with you next time, and we'll keep practicing our Lewis diagrams. Thanks!